Okay, so what I'd like to do then is we've already done all these problems using the modified completing the square, but I'm going to redo them using our vertex formula. So the idea again was to graph f of x equals 2x squared minus 12x plus 10. We're still going to find the y-intercept like we did, and we still know what a is 2, right? So that, again, this is still going to follow. But to find the vertex, we've just found out that h is negative b over 2a, and k is the function value at that h value we find. So it's all about finding our h. Well, in this case, a is 2, b is negative 12. So when I plug that information in here, we get that. Doing the math, the opposite of negative 12 is 12, 2 times 2 is 4, and we find out that h is equal to 3. No surprise, because that's what we found using the ground and pound modified completing the square. How do I find k? Well, all I got to do is plug that 3 into the function. So we come back up here, or right here. This is 2, 3 squared, minus 12 times 3 plus 10. This is 9 times 2 is 18. 12 times 3 is 36, and then plus 10. 18 and 10 is 28, minus 36, and lo and behold, we get negative 8. So there's your k value, which we already knew. All right, and so basically graphing my vertex is at 3, negative 8. My y-intercept we earlier found is at 0, 10. So I plot that point, get my axis symmetry, plot that point, and we basically get back where we started. But maybe it may be in an easier way than all that. But again, here's where all the good math is. This is just a shortcut. All right, so how about, here's a couple more that we did earlier. All right, so another one we did was these two. Again, we already did the ground and pound way. Again, we would still find the y-intercept, we'd still find a, but how do I use the vertex formula to do that? Well, h is negative b over 2a. And in this case, my b is negative 4, and my a is positive 1. So negative of a negative 4 is 4 over 2, we get 2. So h is equal to 2, just like we already know. How do I find the k value? Right? Well, k is my function evaluated at 2. So putting it in up here, we get 2 squared minus 4 times 2. This is 4 minus 8. And what we get is negative 4. So k is negative 4, just like we found. So the vertex is sitting at negative 2, 4. We got it. The y-intercept was sitting at 0, 0. Draw your axis of symmetry, your symmetric point, put it together, and we could have graphed that a little easier using the vertex formula. But again, here's the good math. Here's the kind of the shortcut. All right, and one more, and then I'll go do some harder ones. Or maybe I'll have time here because we're only at 3 minutes. So we've already done this the ground and pound way, right? We found the y-intercept. We know that a is equal to negative 2. But in terms of the vertex formula, this is what this would look like. So my h is negative b over 2a. So my b is negative 8. So we have negative, negative 8. And my a is negative 2. So upstairs we have 8. Downstairs we have negative 4. So we end up with h is equal to negative 2, which again we already knew. Right? To find my k value, we basically plug this h value we found into the function. So we get negative 2 squared, minus 8 times negative 2 plus 1. Negative 2 squared is 4, times negative 2 is negative 8. This will be a positive 16 and plus 1. We have 8 plus 1, and there's 9. So k is 9, which we already knew. We plot our vertex, we plot our y-intercept, use our axis of symmetry, and we'd have gotten the same result. Maybe a little faster and maybe a little cleaner. And yeah, I think I'm going to keep on going on rather than making 2 videos. I think I can get this all done in 1. So what about these harder ones? Well, same thing, right? So I've already done the hard work via the completing the square. Excuse me. So to find my h, if we're using the vertex formula, h is negative b over 2a. So in this case, b is 1 and a is 1, and we end up with negative a half, right, which we knew. Okay, so how do I find k? I find what the function value is at negative 1/2. So we have negative 1/2 squared plus negative 1/2 and then minus 6. This is going to give us 1/4. That's minus a half and minus 6. If we make everything in terms of force, right, that's what everything would be. 1/4, 2/4, and 24/4. So we add all this up, we get a 4. 1 take away 2 is negative 1, right? Minus 24 gives us the negative 25. So k is negative 25/4, which again we knew. So there's my vertex. We can plot it. We know our y-intercept. We can plot it, use our axis of symmetry, and we're off to the races. So there's your vertex formula. I'm not going to bother doing the last one. I'll let you guys maybe do that for practice. I think the point's been made. So again, to kind of summarize what's happening here, right? When we start off with something that is in general form, what we want to do is convert this to the easier standard form. And we have two ways to get there, right? There's the modified completing the square to get the job done. Again, very math oriented, so make sure you understand how to do that. You will use this modification process in this course and in later. Or there's the formula, the vertex formula. On the quiz, I will be asking you to do both. All right, and what's kind of cool is if you have time, you can actually use it to check each other, right? So when you do modified, do the vertex formula to check. When you do the vertex formula, do the modified to check. So two ways to do the same thing, and makes our graphing life easier because, again, that's a nice easy way to graph. We know what the vertex is. We can find the y-intercept relatively easy, use our axis of symmetry, and we're off to the races. So there you have it. We're going to finish this off by doing some applications, and of course I'll be doing that in some videos coming soon.